Hello, a good evening, afternoon, or morning to everyone, depending on which time zone you may be in today. Welcome to this second webinar today, or the second in the series if you took the one of yesterday as well. This one regarding who we are as Barco Residential, what we do, how we go about doing it, and our USPs. Now, today, both Andy Jones, the sales engineer, and myself, Bart de Vos, will be talking to you. For everyone's reference, we are recording this session, including audio and video and slides for future reference. So if anyone would have a issue with that, now would be the time to mention so. But if not, we'll just continue right now as planned. I see it's a one past the hour. Maybe wait a couple more seconds until we kick off, give a chance to some other people to join.
So I'd suggest if we kick off, Bart, and then we can, let a few people catch up as they join.
Yeah, indeed. So today, like I said, this one is about Barco Residential and our USPs. Now, before we dive into the nitty-gritty of things, I want to start off with the building that is shown here on the picture. For those of you who might not have seen this this picture or this building yet. So what you're looking at here is our headquarters in Kortrijk, Belgium. We've got around 1,200, 1,300 people working here. Obviously, in these circumstances, in the current circumstances, that's slightly different, meaning most people working in the offices are doing so from home. But everything regarding our operations, manufacturing, shipping is up and running. So we are actually very much open for business and doing pretty fine. But actually, that's not the main thing that I wanted to share with you regarding this. What we have inside our headquarters is not just office spaces, manufacturing spaces, and things like that. What we have here also are a couple of different demo facilities. So in Barco, we've got three main divisions. I'll come back to those later on. But in short, it's entertainment, enterprise, and healthcare. And we've got different demo facilities for all of these divisions. We also got some demo facilities for the Barco residential activities that we do. And the nice thing that this would offer for you or for your clients, architects, influencers, interior designers that you're working with, is that if you're in the region, you can definitely come by for a tour of these different demo facilities, because that gives you everyone a good overview of the type of activities that we're active in, the technologies that we have and that we're developing, and give you a broader view of the overall Barco activities as a whole. Now, in terms of distance or location, let's say Kortrijk is situated about 1 hour and a half from Brussels Airport. We're about 30-35 minutes away from Lille, if you would be on the Eurostar coming from London or from Paris, or using the TGV coming from Paris. So pretty convenient, pretty easy to reach. If you want to drop by, the only thing that we would like to ask is that you give us 3 to 4 weeks notice, because we got on average 75 visitors coming through per day. So since the opening of the building, this new headquarters back in 2016, we've had way over 50,000 visitors in total. So that's quite a bunch to manage for our colleagues in the Experience Center. Now, having said that, I would like to dive into a little bit more information about, or background information about who Barco is and what we do, because we realize that we may not be on top of everyone's minds, certainly not end clients or designers, architects, etc., because we realize that we're not a consumer electronics brand, plain and simple. So we realize we do not have let's say the cachet of a company like an Apple, for example, to name but one. But it is not to say that we are a small company, far from it. Ever since 2012, we've been realizing a turnover of plus 1 billion euro every year, and that goes along with healthy profit margins, etc. So just saying that Barco as a whole is a very healthy company. We've also been around for quite some time. As you can see here on this slide, we were founded in 1934. And actually, we got our start in the consumer electronics space. So our founder was manufacturing radios in Belgium using American-made components, and that's what gave the name to our company, Belgian American Radio Company, BARCO, Barco. Now, we started out in consumer electronics, but that gradually evolved through innovation, mutating with the market and the market requirements to a purely B2B situation, which is where we are today. And of course, Barco Residential being the outlier in that, where we have the touch point with consumer electronics, albeit at the very high end of that consumer electronics space. Now, looking at the three divisions that I hinted at on the first slide, talking about enterprise, healthcare, and entertainment, to give you an idea about what these activities entail, when you think about enterprise or talk about enterprise, think about things like control rooms, large video walls for oil and gas exploration, electricity monitoring, monitoring of traffic in large cities like Rio de Janeiro, New York, London, for example. But also think about meeting rooms with a variety of technologies involved. Think about LCD video walls, direct view LED, projection, obviously, and then also ClickShare, which is a meeting facilitating solution. Now, if we jump to healthcare, there we are talking about things like diagnostic imaging, surgical imaging, typically LCD type of solutions with software support behind that, but also about more and more solutions for the dentist section of healthcare, and things like a skin analysis device called Demetra, which was launched last year, which facilitates the detection of potential skin cancer or other lesions. And then third is entertainment. This one includes cinema, simulation, events and Pro AV, and also the Barco high-end residential activities. As mentioned, we're headquartered in Kortrijk, Belgium. We've got our own facilities for sales, marketing, customer support, R&D, manufacturing, all over Europe, North America, and Asia Pacific. On a global basis, we've got 3,600 colleagues working with us. That's located in over 90 countries. And from a technology, from an IP point of view, we've got well over 400 granted patents. Now, who are we as Barco Residential? Well, like I said, we're part of the entertainment division, and we are a team of people leveraging the different Barco technology DNAs, let's say, that are there in the company for our own use to create a unique product portfolio, which is specifically tailored for the residential market. Now, obviously, we're borrowing quite heavily from digital cinema, first and foremost, but we're also actually able to cherry pick different technologies, such as borrowing from our simulation brothers and sisters, where we are able to use the power of warp, which enables us to do fancy and very powerful stuff when it comes to integrating our projection technology in a nicely aesthetically responsible way, let's say, something that will appeal to architects and interior designers. I will come back to that kind of solution later on in this webinar. Now, it's important to highlight a couple of differences between Barco residential models and Barco, let's say, commercial models. First and foremost, let's talk about the CinemaScope models. This is something that ties in with film, with movies, obviously, and that is something that is not available in the commercial model lineup. But we're also talking about optical adjustments, such as contrast enhancement, because our projectors are derived from models that have quite a bit of brightness on tap. And typically in the residential space, we do not require that abundance of light. So we are able to sacrifice, let's call it, a bit of light in order to improve contrast. We're also able to improve color fidelity through our different color wheel options. And again, color wheels is something that we'll touch upon later. And then things like 16:9 aspect ratio for our residential models versus 16:10 aspect ratio for the commercial models. Again, the requirements of, say, simulation markets and simulation environments are different from what we are doing and working with in the residential space. Last bullet there is mentioned is special optics. What do you think about that? Well, we're talking about different integrator rods, for example. We're talking about special lenses that enable us once again to do powerful and very nice stuff in the integration of our technology within a theater or a media room space. A Coming on to our philosophy, the simplest of tastes, but always only satisfied with the best. Now, what we want to address here with this slide is a question that we sometimes get, being, do you guys, as Barco Residential, see a possibility, or are you planning on working, or call it what you will, developing a projector that would retail for, let's say, 12 to 15,000 euros? The short answer is no. The more, let's say, the more detailed answer to that is there are a couple of different factors that come into play, right? First of all, technology evolves, becomes more powerful as it goes along. So it's not to say that 5 years from now or 10 years from now, we might not be able to do that. It's just that at this point in time, we do not see a possibility to develop, manufacture, and sell a projector for that kind of price point while still maintaining superb high quality, which is what we're after first and foremost. We do not cater to let's say mass consumption products. We are not playing in that red ocean. I mean, there's different manufacturers, other manufacturers that are doing so, and they're doing a good job, but that is not where we want to play. We want to play and we want to address the different needs that we see popping up more and more, which is larger screens. People are not satisfied with a 2.5 meter wide screen. They want 4, 5, 6, 7 and above. So that is why you need powerful machines, and that is why we simply cannot manufacture a projector that would retail for 15,000 euros and maintain superb quality. Talking about quality, we like to talk about what we call the image quality puzzle. So there's a couple different elements here which you see displayed on this slide. And when we talk about image quality, a lot of people seemingly automatically tend to go for resolution as a pinpoint indication, let's say, for quality of your picture. That's not to say that resolution is not important. It is very much important, but it's just one factor of what will define your overall picture quality on the screen. Now, the 6 elements that you see here, imaging device, luminance, the color accuracy and uniformity, the frame rate, the contrast, and yes, the resolution, these are 6 elements that we as a manufacturer of projection technology have under our control. Now, let's cycle back to the imaging device for a second here. If you're talking about replicating the theatrical, the cinematic experience from the commercial environment, let's say, into the high-end residential space, then you will need and want a lot of brightness. You will want stability. You will want product longevity. And these are all things that DLP technology offers. Nice thing to keep in mind or mention for those of you who might not know, Barco is the market leader when it comes to digital cinema worldwide. Now, over 90% of all cinemas worldwide are using DLP technology, and of that, Barco has 52% market share. In some countries, that goes up to 70-75% easily. But also, contrast is an interesting one. What we are quoting in our specs is the ANSI contrast figure. So we're talking about 450 to 1, for example, 500 to 1, all the way up to 1100 to 1 for our Thor and Thor Plus models. Now, if you would compare that purely on paper with other manufacturers' models where they quote figures like 500,000 to 1 or even infinity to 1, which we find unbelievable and almost laughable, honestly speaking, of course, on paper, those figures will pale. But the thing is, ANSI contrast is a much more representative way of how we watch real life content in the real life world. Talking about moving images, be it sports games, be it video games, be it television, be it watching a movie. And then coming on to resolution, yes, like I mentioned, it is definitely important. But the thing to keep in mind there is that not all 1080p or not all 4K content is created equal. Well, what do we mean by that? If you would compare, for example, a Netflix stream or an Amazon Prime or something from an Apple TV to the signal that you get from a Kaleidoscope unit or the equivalent 4K UHD Blu-ray title, the physical disc, you will see that you get actually a much better quality from those physical media or from a Kaleidoscope than something like an Amazon or a Netflix stream. So let's just say that not all 4K is created equal. And with that, I would like to hand it over to Andy Jones.
Excellent. Thanks, Bart. Excuse me. So moving nicely on from resolution, obviously a key component of that is the ability to be able to resolve the resolution of the incoming video signal and to accurately and precisely display that on the screen. Now, MTF, or modulation transfer function, which can also be described as modulation of contrast or optical resolution, as I'll be referring to it from now, is one of the most widely scientific used methods of describing the performance characteristics of a lens, and essentially describes its capability of resolving information from the incoming video signal at more and more minute, finer resolutions. One of the analogies that I frequently use when I'm talking about optical resolution, whether it be to end customers or integrators, just to help understand this concept, is if you think of a projection system similar to that of the outside world, whereby the incoming video signal, whether it be 1080p, 4K or otherwise, is what I see, the outside world. The projection screen is my brain, i.e. the image portrayed by my eyes, and the optics of the projector are my eyes in the middle. Now, for those of you that can see me on camera, I wear glasses, so I've not got the best of eyesight naturally. And I liken what our competition do by perhaps having inferior optical quality to my average eyesight. If I remove my glasses, my eyes, my lens isn't capable of resolving that high quality incoming signal to the screen. As soon as I put my glasses on, my high quality optics, all of a sudden I'm capable of resolving that image and displaying it correctly on the screen with all of the nuances and detail that the director intended. Now, there are other elements to this. Barco don't do what our competition do, which is we have a multitude of different lenses for our projectors. We can see these displayed on the right-hand side of the image as I scroll through. We will use or restrict the throw ratio capabilities of lenses and design a lens that has or works within a certain throw ratio at very, very high resolution. We're not restricted by trying to manufacture a lens or perhaps two lenses that cover a very wide breadth of throw ratio capabilities, which inherently minimizes optical quality. Instead, we seek for having perhaps 5 or 6 different ranges of lenses for each product, so that we can opt for the highest possible quality lens for each different throw ratio. It also means that we don't sacrifice light output as we transition through the zoom or focal range of the lens and as we transition through f-stops. So we keep the light output of the projector as high as possible as we transition through zoom. Likewise, we keep the uniformity of the lens very, very high, not just at the center of the lens, but obviously across the lens. So as we start to use lens shift and move the image towards the extremities of the lens or the imaging circle, we don't notice as severe drop off in light output or shifts in color accuracy or anything along those lines. So it's key that we offer as high quality lens optics as possible. And this also comes down to the materials that we use. We ensure that we use very high quality glass as opposed to plastic within our optics. The coatings that we apply to the glass and the various optical components within the projector, the build quality, the design, all of this plays a big part in us being able to provide the highest quality image on the screen possible. Now, people think of optical resolution purely as just the primary lens. But there are a number of other components which build what we call the system resolution, or again, part of the optical resolution, which will include things like the imaging device of choice. Barco, as Bart mentioned, use DLP technology, and we're quite privileged as a manufacturer, whereby because we source a large number of DLP devices, we can pick higher quality DLP devices for our projectors more often. It will include things like the integrator rods or the prisms within the projector too. All of these components have an impact on the light coming through the projector and the resolution we ultimately deliver to screen. Now, Barco don't manufacture optical components ourselves. We're not an optical specialist in that regard when it comes to manufacture. However, we do have an internal optical division that work on designing the optical elements for us, ensuring their design is optimized to deliver the highest possible quality. And we work incredibly closely with our vendors to deliver upon a number of key design criteria set out by us. So these criteria will include things like the focus capabilities of the projector. We want that to be as good as possible whilst having minimal distortion to the image, also giving us the good depth of field that we require from the image. We want minimal color errors whilst keeping uniformity across the lens as high as possible. Some of our optics will be designed either specifically for brightness or contrast applications. So if we look at some of our DCI projectors, for example, often we have different lens options where you can have either a high contrast or a very high contrast lens. We often use the very high contrast lens in those scenarios because in the residential segment, we don't need the light output of the projector, so we can sacrifice some light output to benefit from the contrast. And then likewise, the quality of the glass and the coatings that are used on that lens. So all of those elements combine to allow us to take that incoming 1080p, 4K or otherwise video signal and actually ensure that we are displaying it at that resolution on the screen itself, and we're not compromising that by having a poor quality optical engine within our projector. Now, the next part of the jigsaw puzzle is image processing. Image processing is incredibly important, and this ties into a process that we have at Barco called single-step processing, which outlines how we treat that incoming video signal and then reproduce that on screen. Now, first of all, I'd like to talk about how our competition approached this before I go on to talk about how we approach it. And there are typically three processes that go on when we look at image processing. The first part of this is scaling content. In the residential sector, we deal with a number of incoming video sources, each of which have their own resolution. That could range from some set-top, whether it be cable or satellite terrestrial broadcasts that might have 720p through to 4K UHD outputs, and that might vary from channel to channel also. We have the likes of Apple TV, NVIDIA Shields. We have Xbox, PlayStations, Kaleidoscope. All of these different sources have different output resolutions. So first and foremost, the projector needs to scale all of those incoming signals to 4K resolution. Then, depending on the application, we may need to manipulate the geometry of the image. Now, for Barco, we call this warping, but for most of our competition, that would be the form of keystone correction. So if the image isn't aligned correctly, the manipulation has to happen to the image. And that happens at 4K resolution, which of course, because of the number of pixels we're talking about, requires a huge amount of processing capability from the projector to do that correctly. And then the final part of the process is preparing the image for the imaging device. And by that, I mean the projector has to understand for each and every pixel how bright that pixel needs to be, what color it needs to be, if we have distorted or manipulated the image, where that pixel actually resides on the imaging device versus where the incoming video signal says it should reside, and then it's output to the screen. Now, the problem that our competition has is these three processes will typically happen on three individual chips and circuit boards within the projector, which means that the data of that video signal needs to be transmitted throughout the projector. And this inherently leads to loss of detail, possible addition of artifacts, but also increased latency, which can have a big impact on what you see on screen. Certainly from a latency perspective, if you're a gamer, that's a huge issue, whereby the input signal you put in to the controller may not be accurately represented on screen. Or likewise, it may be that you have audio and video sync issues. So the way that Barco approached that is with our single-step processing. And what this means is we take all of those three processes that I've just described, and we do that in a single step on a very high-powered FPGA within the projector simultaneously. So all of those processes happen at exactly the same time within the projector. And this means that we minimize latency to such a low value it's imperceivable. Likewise, we avoid any loss of detail. Now, this is really, really key because it means that we can do image manipulation plus also image processing at a very, very high level without any impact to image quality. And that ties in really, really nicely to what we call our warp engine. Now, hopefully we all know that if we don't align our projector correctly, or if we have to work outside the limitations of our horizontal or vertical lens shift, the projector itself will become tilted or twisted, and that will create a keystoned image, as shown in some of the images on screen. Now, obviously, that's going to have an impact to image quality, and our competition would use keystone correction to manipulate that image and reproduce it on screen. The downside with keystone correction is it has huge detriment to the quality of the image. I'm sure everybody's seen that and will know that on the slides that I'm presenting here that are text heavy, or if you were looking at the synopsis of perhaps a Kaleidoscape or otherwise, all of a sudden the text becomes very illegible, things don't quite look correct on screen. Barco use a simulation grade warp engine. Now this warp engine or simulation grade warp engine derives from our simulation division, and Barco Residential tap into that. And this is used in a number of applications, whether it be aviation flight simulation, it could be driving simulators for Formula One teams or otherwise. And in these applications, often we're using multiple projectors, 3, sometimes 9, sometimes even more, blended together, often on a curved or spherical spherical screen, where we need to manipulate that image to match the shape of the screen whilst not impacting image quality. Now that's key. It means that we can correct the image if we are outside of our lens shift capabilities, to ensure that the image looks as good as it possibly can. And we have two functions we typically use within the residential sector. The first is four corner warp, which you can think of as our keystone correction, but keystone correction that has zero impact on the image quality. Now, what we can do is we can grab any one of the four corners of this distorted blue image where the projector is twisted and pull it into the correct position to create our ideal image. Now, typically this is where if I was presenting this to people face to face, I'd be able to jump onto one of our projectors that we'd have in the room and show you how this is done. But for the purpose of this presentation, I've extracted a couple of screen captures from our web interface that we use for setup of our projectors called Prospector. Now, this is where we grab each of the corners, and we can literally grab that corner and move it to the correct position we need to if we need to make large adjustments. Then over on the right-hand side, more granular, pixel by pixel, we can adjust the image either horizontally or vertically as required. So that allows us to correct the geometry. And it also means that although we would highly recommend you get the alignment of the projector absolutely spot on so that you don't have to use the four-corner warp, if needs be, you can cheat ever so slightly and perhaps notch in a corner or two, by 1 or 2 pixels with zero impact on the picture. The other function we use is a function called bow correction. Now, bow correction is another part of the warp engine that allows us to manipulate the geometry and compensate for 2 things. The first is for if we have very short throw lenses, which inherently by their design add what we call a barrel distortion. So this image in the left-hand corner here. And it allows us to true up or straighten those edges of the screen so that we reproduce the square image as shown. The other perhaps more common use case is, certainly I've been working in projection for a number of years, and I historically have sold a number of old Runco projectors to customers using anamorphic lens solutions, which would have created a pincushion effect, like shown on the bottom left-hand corner here, where we would have sold the customer a curved screen to counteract that. Now, unfortunately, a lot of end users don't appreciate the fact that screen technology has moved on significantly over the years too. And they don't realize that projection systems are a 2-piece solution, both the projector and the screen. The screen has an impact on image quality. So unfortunately, because they don't understand that, they often don't upgrade this curved masking screen that may have cost them 20, 25,000 euros or US dollars, because it's a large chunk of change that they don't perceive any benefit from. So one of the things that we can do is we can actually reverse this and take our square projected image and actually add a curvature to that to match the geometry of our curved screen. And again, we can do that from our web interface Prospector by grabbing these anchor points here and manipulating the geometry of the top and bottom of the screen and adjusting either the angle or the length of that. So there are a couple of ways that we can use the warp engine to optimize the installation of our optimize the quality of the installation. But it also ties in very nicely to something we feel very strongly about, which is the architectural integration of systems, whereby we want to hide away everything but the image so that customers have very elegant installations where they don't see the projector, they don't see the loudspeakers, everything is neatly hidden away without detracting from the aesthetic of the room. Now, we have a number of partners that we work with in this, one of those being Display Technologies, who we often partner with at CEDIA ISE and have a number of integrators that use their products globally that we often connect with. And part of the reason for this is with these types of solutions, we can do some quite unique installations, such as the one here, where the customer has a room with a lamp in the middle, which means that the projector can't be located at the back of the room here, where we would ideally like it to be located, so that we just shift the position into the correct place and project onto the screen normally. So what you can see in this installation is the projector is actually tucked right into the corner of the room, way beyond the horizontal lens shift capabilities of the projector, but we can use the warp engine to correct that geometry and display the correct image on screen. Now, the benefit of the architectural solutions is they allow us to hide the projector away incredibly elegantly. And we have a presentation that goes into this in much more detail next Wednesday at the same time slots as we have our presentations today. But in this scenario, for example, you can see our Display Technologies vertical mirror mount with our projector on it, converting the height of the projector into the depth of the projector. So requiring much less space to house the projector compared to putting it at the back of the room with the usual ventilation requirements. This is another scenario where we're using a product called the motorized mirror drop, where you can see if I zoom in closer here, the projector is actually projecting towards the back of the room, being redirected off of 2 mirrors back to the screen. Now, again, if required, we can use our warp engine to correct any geometry needed on the projector. But this is a fantastic demonstration of a way we can hide everything away elegantly, keep any noise of the projector out of the room still, so the noise floor and the audio system can perform as well as it needs to. We have minimal mechanical movements. We're simply moving a mirror up and down into the room rather than lifting a heavy projector up and down and relying on it being in the same position each and every time. So this is just one of many solutions that both we and Display Technologies can offer clients to elegantly hide projectors away into a room without disrupting the aesthetic of the room. And then the final one we have here is one of our ultra short throw solutions, again in conjunction with Display Technologies, where we use one of our 90-degree right-angled lens. And this little hatch in the middle doesn't contain any mirrors. It simply lowers up and down as a trapdoor to allow the projected image from within the ceiling to project onto the screen. So for anybody interested in understanding more about these solutions, how to specify them, the calculations and considerations you need to take, I do urge you to sit on that webinar next week. Another benefit of Barco projectors, as Bart mentioned, is often because of the products that they're derived from our other divisions within the company before they're modified for our individual use cases, is they have an abundance of light output. And this allows us to display images as we wish correctly, like the image at the top here, as opposed to the 2 scenarios at the bottom, whereby either perhaps in some scenarios the projector doesn't have enough light output, or the customer's specified too large of a screen for the projector and their image is dull and not very compelling to watch. Or perhaps they've got an installation like a media room as opposed to a cinema where they can't control ambient light so much, or they want to watch sports events during the middle of the day without having to pitch or plunge the room into darkness, and the image would appear washed out. So there are a number of elements within a projection system that impact the light output, and we'll cover those very, very briefly. So ambient light is a big factor, and to overcome ambient light within a projection system, you need a projector with a large amount of light output. So we can offer that with our projectors. The lens itself, I mentioned earlier, as you transition through the zoom of the lens, you transition through the working f-stops, and this has an impact on the light output. The lens can restrict or increase light output depending on where you are. That's another reason why we keep our throw ratios minimal rather than using one lens that covers a vast breadth of throw ratios. And the light source and the illumination system and the color wheel have an impact, and I'll come on to that in a moment. Video calibration will have an impact. We'll lose approximately 10% when we calibrate the video correctly on projectors, not just our projectors, on any system. The screen surface, the screen gain will have an impact. But also importantly, what a lot of screen manufacturers don't talk about is the acoustic transparency of the screen surface will have an impact. it doesn't matter what type of acoustic transparent screen you use, whether it be microperf, woven, or otherwise. If audio can come through that screen, likewise, we will be losing light through that screen through the perforations in the fabric. And that can be in the region of 20 to 25% of the projected light output. So you need an abundance of light output in the first place if we're using big screens with acoustic transparency. And then finally, you have things like port glasses and mirror solutions, which have minimal impact, perhaps in the region of 1.5 to 3% per port glass or mirror, but still something that needs to be factored in. So as I mentioned, the color wheels can have an impact as well. Now, Barco Residential have a number of projection models with different color wheel options. The Medea, the Boulder, the Loki being 3 examples. And we have 3 color wheel options. We have the media room color wheel, designed generally for media rooms. We have the theatre color wheel, and we have our DCI P3 color wheel. And the analogy I use to best describe these is to think of them as a seesaw, where on one side we have light output, and on the other side we have available color gamut. So as an example, our media room color wheel is optimized to provide greater light output, albeit at the sacrifice of available color gamut. So this is where we really would use it in that media room environment where we've got high ambient light, where perhaps absolute color accuracy isn't going to be, of paramount importance versus the brightness of the image. Whereas on the other extreme, we have our DCI P3 color wheels, which would typically be used within a dedicated theatre environment where light or ambient light is controlled, and we don't need as much brightness from the projector, but we want to get all of the benefits of HDR content and that DCI P3 color space. So we can change the specification of the color wheel, certainly on the Boulder and the Loki, depending on the requirements of the installation. And it can also be interchanged at a later stage. So if you have a customer, for example, that perhaps started off with a media room, moves property or builds an extension and wants to put in a dedicated theatre, we can then upgrade and replace that media room color wheel to DCI P3 or vice versa. We then also have within our projectors very accurate real color calibration process, which is how and what allows us to calibrate our projectors for both SDR and HDR content to Rec 709 and DCI P3 color spaces. So again, this is a screen grab from Prospector, our web interface, which allows us to calibrate to our required color standard. Now, one of the really nice things about this solution is within our projectors, we do a lot of analysis of the incoming video signal, and I'll talk about this over the next couple of slides. But one of the things that we can determine is whether the incoming video signal or content is SDR or HDR content. And providing we calibrate and specify within this menu our HDR mode, the projector can actually automatically switch the color space between Rec 709 and DCI P3 for the customer without the need for them to have any form of interaction with the remote control based on the content they're watching, allowing us to reproduce the content in the correct color space each and every time for them. So because Rec 709 conveniently sits neatly within DCI P3, we're simply using algorithms to change the color space between the two. So that makes the user experience much, much better because they don't need to consider what they're watching. And most of the time, I think it's fair to say that consumers aren't into the technology as much as we are. They just want to know that when they come into their theatre and hit play, that it's being reproduced correctly. They don't want to look at their remote control and perhaps select between one of 6 or 7 different presets based on the aspect ratio type, the content type, or otherwise. We do very similar with how we set up the HDR video signal. So I'm not going to go too deep into HDR because I'll assume that most people now know what HDR is, how it's processed, etc. But what I want to explain is how Barco processed the HDR information. So again, we can understand whether the incoming video signal is HDR or SDR and apply the correct color space. But we also understand the mastering luminance of the content, i.e. whether it was mastered for 1000 nits, 2000 nits, 4000 or other. And that allows us during the calibration process to set the screen luminance for the projector and then allow the projector to change that screen luminance value based on the incoming HDR video signal that it receives. Again, designed to reproduce the content the way the director intended without the customer having to select between different calibration profiles. The next thing I want to talk about, which Bart alluded to in both yesterday's presentation and earlier today, is a CinemaScope, which is or certainly for our implementation, is quite unique to Barco. So the whole purpose of CinemaScope is to take this image, which is letterboxed and displayed within the 16:9 proportion of a CinemaScope screen, and display it as the director intended in its native 2.37:1 aspect ratio using the full real estate of the screen. Now, at Barco, we believe our approach to this is by far the best approach because we do this without any optical distortion through an anamorphic lens or without overscanning and lost resolution within our approach. So how do we do this? First of all, the output resolution of our CinemaScope projectors is 5K UHD. So we actually increase the resolution of content as we transition from 16:9 to CinemaScope. So we output at 5120 by 2160 when watching CinemaScope content. And that resolution will alter depending on whether we're watching 185, 2.2 or otherwise. We manipulate that resolution based on the content we're watching. And as I mentioned, we do that without any zoom or anamorphic lens. Now, one of the great features, again, of being able to analyze the incoming video signal is we can set the projector into a mode called auto cropping, which allows us to manage the content for the customer by understanding whether they're watching 16:9 content, 185 content, CinemaScope content, and we can automatically place the projector into that correct output mode. We can then also provide that information to the connected control system, which can then automate masks on a masking screen to open and close to that correct aspect ratio too, to frame the image and increase our perceived contrast ratio. So that's a really cool feature, which again means the customer doesn't have to have any interaction with what they're watching. Now, the big benefit of this, or one of the other big benefits of this, is it's very fast, easy, and clean to install. And I'll show you that on the next slide in a minute. But certainly I've historically been on sites where, you know, I've been showing integrators how to set up anamorphic lenses, and it's taken, 30, 40 minutes to get that set up correctly. We can do it within seconds. Other benefits is we have no mechanical drift within our solution. We're simply using the DMD to turn mirrors on and off to open up or expand the resolution of the image that we're displaying. With memory zoom, you have mechanical drift potential from the motors that zoom the image in and out to transition between aspect ratios. And with anamorphic lenses, assuming you're not using a fixed lens, which would compromise either 16:9 or CinemaScope image, you have to move a very heavy piece of optical glass in and out of the projector, which again can lead to issues where it's not always positioned correctly. Likewise, we don't have any optical distortion. So with an anamorphic lens, as I mentioned earlier, chances are you're going to have some pincushion effect, which you need to then use an expensive curved screen to compensate for. but also depending on the quality of the anamorphic lens, and they do vary significantly, you may get some chromatic aberration, which again, we don't want. There's also a cost implication. The cost of an anamorphic lens, it needs to be good quality, is likely to be in the region of £7,500 to £15,000. The cost of our solution to go from a 16:9 projector to a CinemaScope projector is a very, very small percentage of the overall cost. And then we also have installation flexibility. And by that I mean we don't need to calculate different throw ratios because we're using memory zoom, where we need to ensure that we can fit both our 16:9 and CinemaScope zoomed image onto the screen with the lens we have, nor do we have the restrictions of an anamorphic lens, which typically have a requirement of a minimum throw ratio of 1.6 times the image width of the screen. With our solutions, we can go right down to 0.4 times the image width using our special optics, or more commonly down to 0.8 times the throw. So we have complete flexibility without any restrictions. And then the final point to make is we have constant light output. So our calibration is accurate and consistent, regardless of whether we're watching 16:9, 185 CinemaScope or otherwise. And we also don't manipulate the size of the pixels. As we zoom in and out, the pixel size is changing. So we're not altering the visual acuity and the size of pixels based on the content that we're displaying. So this is the menu I talked about in Prospector and how easy it is to set up. We can simply force an aspect ratio if we choose. We don't need to use our auto cropping, so I can set it to force to 16:9 or CinemaScope. But to set up correct, or as I would set it up, I would set this drop-down menu to auto, and then I would configure how my aspect ratios are mapped. So that could be like for like if I have a screen that can accommodate multiple masking presets, or if I have a screen that, as an example, is fully open or 16:9 only as a cost-saving measure, I can define that our 185 content is displayed as 16:9, and perhaps our 2.2 content would be displayed as CinemaScope. So it literally takes seconds to configure the system. One of the final pieces of the jigsaw puzzle is the Pulse platform itself. So the Pulse platform is the beating heartbeat of our Pulse projectors. And by Pulse projectors, that refers to the Medea, the Bragi, the Boulder, the Loki, and albeit discontinued, our Wodan platform. Now, there are some key benefits to this platform. First and foremost, we use very high quality electronic processing in the form of FPGAs, which allow us to do the single step processing I mentioned earlier, and the image manipulation in the form of the simulation grade warp engine, whether it be a 4K UHD or 5K CinemaScope content. And we also have a unified platform across the portfolio, meaning Prospector, the web interface, which I've shown you one or two slide decks from, is the same more or less for each and every projector, with one or two exceptions based on whether it's a CinemaScope or a 16:9 projector or a laser phosphor output versus a LED output, as an example. We also have a range of inbuilt diagnostic tools that allow us to review the incoming video signal and various other components within the projector, which we can do remotely or on site. So from a serviceability perspective, when the customer has an issue, we have great ability to be able to look at that remotely before we even step foot into the client's house to get a better idea of what we might need to tackle when we arrive on site. And then upgradability. We do regular firmware updates that offer improved functionality and sometimes new features, providing the hardware permits that, of course. One of the final things I'd like to talk about is our control integration. So we support control drivers for what we would call the big four: Control 4, Crestron, Savant, and very, very soon RTI. But we also have inbuilt within Prospector all of the tools you need to be able to control or input into other control drivers or systems that I haven't mentioned. So we can download the API from within the projector by clicking on the documentation tab. And we can also open up the JSON RPC console, where as I change information within the projector, it will tell me the JSON commands required for that process, which I could then program into my own driver if I know how to write drivers, or into control systems that allow, like Crestron, RTI, to actually input those command strings for perhaps more customized functionality not included within our drivers. The final thing I'd like to mention is everything up to now that I've been talking about predominantly has been from our Pulse platform. So what I would call, perhaps for want of a better word, our albeit very high-end consumer grade product. Although still consumer, we also have another range called the C series, or our Cinema at Home series projectors, which are DCI compliant projectors, allowing us to play back digital cinema packages, i.e. the same content that would be played within a digital cinema, day and date release content, in addition to supporting HDMI 2.2 and HDCP2, allowing us to also connect Apple TVs, Xboxes, terrestrial broadcasts, Kaleidoscopes too, which really allow us to offer the absolute pinnacle of projection performance to customers. So our product portfolio has both great width and depth to it, allowing us to show anything from our entry-level Medea right up to our flagship 4 Plus projector, allowing customers to get the very, very best in performance. And this goes back to the presentation that Bart gave yesterday about showing people what you can offer and not being afraid of pitching high to them, because some customers won't appreciate the level or the product range that Barco has and the quality that we can deliver. So the final piece of a jigsaw that I'd like to talk about just very briefly before we go to the Q&A section is the resources that we have available to us. So first and foremost, we have the Barco Residential website, which talks a little bit about the technologies we have, the product range, etc. Prospector, which is a great resource in terms of setup of the projector serviceability. We have a Barco Residential lens calculator that you can use to check that you're specifying the correct lens or what lenses are available, what lens shift you need. And then we also have My Barco, which is part of the barco.com website, where we house all of our technical drawings, manuals, firmware updates, control drivers. So if you don't have access to this, I'd recommend that you set up for a My Barco account through the barco.com website, selecting the home entertainment segment, and perhaps put my name as your Barco contact, Andy Jones, and that will come through to me, and then I can authorize that pretty quickly for you, so you've got access to those documents. Also worth noting that within that, as part of being locked up in confinement throughout the situation we find ourselves in at the moment, we're creating a number of how-to videos, which will also be hosted on this platform under the training tools section. You can see here we've got 4 uploaded at the moment, so worth having a look at those too.